Hi, it's Miss Townsend. Let's try to solve this question together. So it's actually 5 different questions, but all of them are asking us to do the same thing. Solve for x by writing as a proper quadratic equation, then factoring to find the roots. So a proper quadratic equation is one that's written so it looks like a standard form quadratic equals 0. Once we've written that, then we can factor and try to solve the roots. So, question number 1. This is what it looks like. I'm going to recopy it. Again, I always recopy the question because it helps me really see more carefully what it is that I'm dealing with, as opposed to just looking at a thing. So I have on the left side of the equation a quadratic, and on the right it's a different quadratic, but of course I need it to be one quadratic on the left side equals 0. So I'm just going to collect like terms. So I'm going to subtract x squared. So 2x squared minus 1x squared is 1x squared. Then I'm going to add x. So 3x plus 1x is 4x. And then I'm going to subtract 11. So negative 1 subtract 11 is negative 12. And that leaves me with 0 on the right side. So now I have a proper quadratic equation, and we can solve by factoring if we can find two numbers that multiply to negative 12 and add to 4. And the numbers would be negative 6, positive 6 and negative 2. 6 times negative 2, negative 12. 6 plus negative 2 is positive 4, so I factored our quadratic. And now that it's factored, I can apply the zero principle, which says, because this bracket is multiplied to this bracket, then if I make this bracket equal to 0, 0 times anything in this bracket is still equal to 0. So what number makes that bracket 0? Oops, sorry. What number makes the first bracket 0? Well, it would be negative 6. Because negative 6 plus 6 equals 0. And similarly, what number for x makes the second bracket equal to 0? Because if the second bracket's 0, 0 times whatever this bracket is still 0. So the number that makes this bracket 0 is x equals 2. So I've solved the system. I've got two answers, negative 6 and 2. Okay. So let's clear the screen and look at question number 2. So question number 2, well, I guess B, right here. So we have bracket x minus 5 squared. So that's a binomial squared on the left. And on the right, just x plus 51. So I need to square that binomial so I can see the quadratic, and then I can collect like terms on the left. So squaring a binomial, square the first, double the product. So negative 5x doubled, and then square the last. So I have expanded, and now I just have to collect like terms. So I have to subtract x and subtract 51. So x squared, subtract 1x from that, I get negative 11x, and subtract 51 from that, and I get negative 26. So now I have a simple quadratic that I'm going to try to factor. So can I find two numbers that multiply to negative 26 and add to negative 11? Yes, negative 13 and positive 2. And now that it's factored, I can apply the zero principle and find the actual solutions. What number makes this bracket 0? Well, if this was 13, I would have 13 minus 13, which is 0. So one answer is x equals 13, and the other answer would be x equals negative 2, because negative 2 plus 2 equals 0. So I have two solutions, x equals negative 2 and 13. And if you're wondering, it's just a good habit to write your answers as a solution. And we like our numbers to be in numerical order. So that's why I wrote negative 2, 13 instead of 13, 2. Not a big deal, but a nice thing to notice and try to do if you can. So let's go and look at part C. So part C is right here. And I have x times bracket 2x minus 3 equals 54. So I need to expand what's happening on the left to see my quadratic. So x times 2x is 2x squared. And x times negative 3 is negative 3x. And I might as well subtract 54. So I have negative 54 equals 0. So there's my quadratic. It's in proper quadratic equation form. So now I'm going to try to factor it so I can solve. So there's a 2 in front of the x squared, and I can't common factor it. That makes this a complex trinomial. So here's my brain. I need to find two numbers that multiply to negative 108 and add to negative 3. So 108, that's not a number I necessarily know offhand, what multiplies. There's some tricks that you learn the more you do. Like, because this is such a small number, I know that the two numbers I'm looking for must be really close together, right? Like, I know it can't be 1 and 108 because those are 107 numbers different, right? So sometimes you can just find the numbers faster if you think like that, but there's nothing wrong with just sort of trying and scrolling through what are all the things that multiply to 108. So 108 divided by 3, that's 36. Divided by 4 is 26. 5 doesn't work. 108 divided by 6 is 18. Does it divide by 7? I doubt it. Doesn't. What about 8? Let's try 108 divided by 8. Oops. Sorry. My hand and my brain were not thinking the same thing for a second. Doesn't work. 108 divided by 9 is 12. Oh. Remember, I'm looking for two numbers that have a difference of 3. And 9 and 12 are going to be those two numbers. I just have to put the correct signs on them. So I want them to multiply and add to negative 3. So I need positive 9 and negative 12. So I can now continue factoring. So I break down that middle term. So it's the decomposition method into positive 9x and negative 12x. And just, notice that I'm not putting an equal sign in front because there's already an equal sign there. So keep going. I'm going to common factor the first two. And there's not that much in common, but I can factor an x out of both. And that will leave me with 2x plus 9. The second two, those are both divisible by 6. So I'm going to factor negative 6. So factor negative 6. This would become positive 2x. And that would become positive 9. And happily, I'm on the right track because my brackets match. It's still equal to 0. So I have 2x plus 9 in one bracket, and the other bracket is x minus 6. And now I factored it. So having factored it, I can now solve for x because it's factored and equal to 0. So this one I can tell right away. That's just x equals 6. And don't forget that there are some shortcuts you can discover. But I'm just going to do this one the longer way. And it's not that long. To say, well, I need that bracket to equal 0. So what x value makes that happen? So I'm now just solving for x in a grade 9 linear equation. And I get x equals 9 over 2. Negative 9 over 2. So there's my two answers. So I will write that x is negative 9 over 2 and 6. And those are the answers to that question. So let's clear the screen. And we can look at the next question. That one took a while because of complex factoring by decomposition. Okay, so let's look at question D. So D has a bunch of things with brackets and squares on the left. Oops, sorry. That's my writing implement. Just messed up. Okay. Plus x plus 2 squared equals 110. So clearly I have some brackets to expand on the left, and then some terms to collect, I bet. So I have x squared plus, I'm going to square that bracket. So square the first, double the product, square the last. And then I'm going to square this bracket, square the first, double the product, square the last. And I still have equals 110. So on the left, these brackets are all doing nothing but have a plus sign in front of them. So if I was multiplying in front of the bracket, or if there was a minus sign, I'd have to be really careful and write another step. But because it's just plus, then I can basically ignore the bracket or multiply by +1. And either way, I'm going to now collect like terms. So I have x squared plus x squared plus x squared. That's 3x squared. Then I have 2x plus 4x is 6x, so plus 6x. Then I have 1 plus 4, which is +5, and that equals 110. And then finally, I'm going to subtract 110. So I get -105 equals 0. So now I have it in proper quadratic equation form, and my goal is to factor. So let's see. Is every one of those numbers possibly divisible by 3? That would be lovely. I know 3 and 6 are, but is 105 divisible by 3? Yes, it is. So I'm going to common factor out of 3. And by the way, if you don't know, there is a fast way of checking if a number is divisible by 3 without a calculator. I know it's divisible by 3 if the sum of the digits is divisible by 3. So I did 1 plus 0 plus 5 is 6, and 6 is divisible by 3, so it's divisible by 3. Look, some bonus knowledge right there. So I factored out the 3, and what I'm left with in the bracket is a lovely simple trinomial. So hopefully I can find two numbers that multiply to -35 and add to +2. So -5 and +7. And now that it's factored, I can apply the zero principle and actually solve for x. What number makes this bracket 0? X equals 5. What number makes this bracket 0 is x equals -7. So I have two solutions. So my answer to the question is that x equals -7 and x equals 5. Okay, so let's clear the screen and look at the next question. Okay, so that was D. So let's look at E. So question E, right here. So I've got 2 times a binomial times another binomial equals a binomial times another binomial. So I've got binomial expand math to do on the left and to do separately on the right. So let's do that math. So I'm going to not multiply by 2 to start with because it'll just make the numbers bigger, and I'm more likely to make an error with bigger numbers. So I'm going to multiply the brackets together. X times x is x squared, and x times -2 is -2x. Then I'm going to -1 times x is -x, and -1 times -2 is +2. So let's do the same thing on the left. I'm not going to put a bracket this time because there's no number multiplied in front of this. So I'm just going to multiply x times 4x, and then x times 1, +x, -3 times 4x, and then -3 times 1. So let's see what's going on. Now on the left, I still have 2 times that bracket. So I'm going to, first of all, I'm going to collect like terms. So you can see that in the bracket, I have -2x minus 1x, so that's -3x. On the right, I have +x, that's +1x, minus 12x is -11x, and then -3. So multiply 2 into that bracket. And I finally have all of the math taken care of separately on the left and the right. So now I'm going to collect like terms. So I'm going to subtract 4x, then I'm going to add 11, and then I'm going to add 3. And now I have a proper quadratic. So just so you know, it is totally fine to collect terms to the right. It's just, you just get in the habit of everything should be on the left. And so that's my habit. So let's look what I have. Well, first of all, I have a negative number in front of x squared. Don't like that. Maybe I should have collected stuff on the right. By the way, just, in case you're not sure what I mean by that, is if I had moved all of the terms to the right side, I would have that. So it's mathematically the same thing as what I have written. And it means I wouldn't have to do what I'm about to do, which is factor out the -1. It's just, again, habits. We do want the x's to the left, right? So one important thing is, if my answer, let's say I get an answer of 3, you do not want to write that, because my goal is to solve for x. X equals 3 is a solution. But 3 equals x isn't quite communicated correctly. So it's just one of those habits, math habits. So I'm going to factor out -2, and I don't see anything else that I can factor out. I'm sorry, I'm not factoring out -2. I'm factoring out just the negative sign. Negative. So this becomes 2x squared, and then I'll have minus 5x minus 7. And now I can try to factor that quadratic trinomial that's in the bracket. So it's a complex binomial. So I'm just going to sort of go to the side here to do some of this factoring, only because that way I don't have to worry about copying the negative sign in the bracket every single line. And that's a good strategy for communicating properly. So I have a complex binomial. Can I find two numbers that multiply to give -14 and add to give -5? Well, positive 2x and -7x are the numbers I'm looking for. So now I'm going to common factor the first two. And then I'm going to common factor those two. And then this bracket matches this bracket. And this is 2x minus 7. So if you're wondering why, with this green pen on the right, I haven't put equal signs, well, because that's not the main math I'm communicating. That's like, over here, if you want to see how I factored, look over here. But it's not like the proper communication of the solution. It's like, here's some math that's important, but it's not the overall flow. So the communication there is less important. So now that I've factored, though, in my properly communicated blue ink, I can write the factored form of that equation. And of course, now that it's factored, I can solve for x using the zero principle. So here I get x equals -1. And here I get x equals, well, let's find out. I'm going to make the bracket equal to 0. So 2x equals 7. So x is 7 over 2. So I've got two answers. Put them together. And I have the solution. I have solved for x.